Okay, continue. Okay. This one you go home read. This one you go home read. This is a derivation of the du and all this. This one you read. Not inside your test scope. I want to ask you on the derivation. Now, what is important is equal. You have tangent and normal direction, right? A equal to AT UT plus AN UN. Just remember, acceleration you have tangent because you are focusing on the object. The acceleration have tangent direction and normal direction. So you write AT UT is a unit of tangent direction plus AN in the normal direction, and the UN means the unit in the UN. So this is the first equation we expect from your answer. And then you jump to the top one. You expand from this equation, AT equal to V naught. How to get acceleration? Acceleration is the differentiation of your velocity. Right? Now, how we can straight away take the V? Take the V and differentiate Y. What do you solve for? What direction you solve? You solve for tangent, right? What is the, when you draw a curve motion, where is the V direction? Always tangent to the curve, right? That's why here you can straight away take the V and differentiate with time for the AT. Understand? You are given the V direction. So you take this V tangent direction, differentiate with time, you get AT, right? Understand? I go too fast, is it? Okay, if you have a curve, If you have curve and the object move from here to here, you know that every time you focus on that object or particles, you know that you have two axes. One is tangent, one is normal. You know that the center of this curve is this direction. Okay, so you have this one already. Then every time you have the object moving on a curve, you know the velocity always tangent to the curve, right? This is your V and is tangent direction, right? So you have a Vn also, but we skip that later. So this is 90 degree to the tangent. So that's why when we differentiate this one, dV dt, you get A, right? But this one is tangent direction. So you can label your A is AT. You're finding acceleration in the tangent direction, which is this one. That's why you can write V dot. Yeah. UT is the unit like your IJK in the Cartesian plane. UT is just a unit for the object, the axis on the object. Like your IJK part, we use UT and UN. Understand? Okay. Now, another one. Then you move to AN. AN, just memorize this equation. In your answer, you replace AN equal to V squared over rho, you get 1 mark. Anytime the question asks you to find normal tangent component of the object, you write AN equal to V squared over rho, you get 1 mark. Okay, so basically these are the two important equations for okay. This slide is to tell you the direction when you see an object moving from it on this diagram is moving from the left to right. When you see an object moving on the curve and you're focusing on the object, when you're focusing on the object, you no longer use X and Y, you use normal and tangent axis. And it's always stay on the body of that body, right? So this particles is moving along the curve. Observe the arrow for tangent. Arrow always follow the motion of the object, and it's always 90 degree to the normal direction. And the normal always follow the curve direction. The curve always pointing inside. So this one you have to be sure. If you don't know this direction, you cannot do this kind of question. You cannot do. You are lost. You don't know how to start. Okay, first you have to focus on the object. Then you have to able to understand where is the tangent direction, either go to the left or right, always follow the motion, and then where's the normal direction. And this object is moving on the curve. Huh? Okay. The second point here, you see the arrow flip. The arrow flip is because of the curve. The tangent always follow the motion and it's always 90 degrees to the normal direction. So that's why your arrow is look like this and the resultant is like this. This is what you learn from your vector chapter in mathematics. Yeah? Who don't understand why the arrow like this and then the arrow like this? Yeah? Okay? You don't okay. Okay. Okay, first you understand where is the tangent and normal direction or not? You know how to derive this central resultant arrow or not? Was it? You know how to derive this resultant or not? Okay, recall your vector. You have two vector. This is quite straight. Two vector which is 90 degree to each other. You have vector A, vector B. Where is the resultant? How you know it's going there? The dumbest the stupid way is what? You copy this arrow and draw a parallel line. And you copy this arrow to the same height. And then you start from the origin, pointing to the intersect of that point. This is how you derive. So you combine what I write on the smartboard and these two. That's why the arrow pointing here. And then this one is pointing up. Okay. Okay. Now, what is interesting is always you will see in final exam. What if the question asks, say, if the object moving in the straight line, what happened to your normal and tangent direction? If it's moved in a straight line, just now on a curve, right? Curve, you know the normal and tangent, but now the object moving in a straight line. What happened to the normal direction? Why? Why an equals 0? Why? On the curve, you see an, right? But then the object move in a straight line. Why suddenly an becomes 0? Not the correct answer. Why we move in the straight line? Why your AT is there, but an is 0? Why? Look at this equation. An equal to v squared over rho. If your straight line, what is the rho value? Not 0. It's a very large radius, right? If you enlarge the circle, you can see flat line. If you have large enough circle. So what happened to your rho radius is infinity? This one near to 0. That's why your an don't have during flat line. This is how you explain to your juniors when your junior asks you why an object moving in a straight line, normal component acceleration don't have. You use this equation, explain to them. Because straight line is a big large of circle that is almost flat, and the radius is infinity. It's very, very big number. So when you have very big number on the denominator, you get almost near to 0. Yeah, that's why I mentioned this slide is important. This slide is important. It's explained why when you move in a straight line, you only see AT component. AN 0. Why AT 0? You move to these slides and you write AN equal to rho V square over rho infinity AN 0. Yeah. Now once you have this one, you can do question already. In 3D, you need to go to appendix B and C. Okay, just now 2D, you have tangent and normal. When you have 3D, we have one more direction. We will use right hand rules. Right hand rules. Okay. Your thumb is your end. Thumb is your tangent, means the direction of your motion. Your thumb is the direction of motion. This stiff finger. Okay, this finger is the normal direction, right? If I put on my bodies, I'm the object, and I move on the curve. Let's say I move in this curve, right? I move in this curve like this. Okay. So this what finger we call? Jari apa? Telunjuk, always pointing inside the curve, and my thumb is always my motion. Okay. So of course when you do question, you don't move around lah. Okay. In 3D, your middle finger is the Z direction. Okay. It's a Z direction which is come outside the paper, which is no longer a planar question. It's a 3-dimensional question where you use right hand rules. And this one, your thumb, important is your thumb and this one. And the middle finger here is pointing up. It's always 90 degrees to each other. Always 90 degrees. The rest I will teach you how to do, right? What is important is the direction. This one you just read through. Read it through. So far, I don't ask 3-dimensional question yet. Only we stop at 2D. Okay. But 3D, when it comes to FYP and maybe on the satellite design, that one. Okay. So you have a cross product. Just remember, cross product of 2 vectors, you need a certain procedure. Okay. Now, just to recall, using your right hand rules, how to find the middle finger, UB. UB is a XYZ, is a K component. How do you find the UB? Is you take the T cross T, T cross N. T cross N, anti-clockwise. Because you know vector is always anti-clockwise. It's a cross. Okay? Your thumb cross to the N component is it give you a positive value of your Z component or B component. Okay, like this. It's like you're firing something, right? Your T cross to N, you get positive B. It's a matrix. It's basically it's a vector, multiplication of vector. I won't test you lah, this one. Okay, how to find N? How to find N? Just use your left hand rules. You just N is like this one cross this one. B cross T, right? U cross to N and then B cross to T. Okay, but this one is not important. This one you read. This one you read. You read, huh? You read. You see familiar? These three formula is the 3 Newton equation. So you can use this 3 Newton equation for object curvilinear motion in the normal and tangent direction. You just need to do modification. Remember, an equal to v square over rho. This one will give you 1 mark, bonus mark. Always remember, it's important. Another equation to remember is this one. Remember, this one have to memorize. It won't be given. Huh? This one won't be given. To find the rho of your curve, the radius of your curve. This one you need to memorize. Huh? Is a bracket of 1 plus dy dx square. And then you have a cube and a square root. 3 over 2 is multiply exponential 3 and square root of this value. And this one, this one. And then below one is double differentiation of your y equation. This is heavily for you need to polish up your differentiation skill. Huh? This equation alone 1 mark, and the answer is 1 mark. So this one will cost you 2 marks. Where does this you need to find? Where you know you need to find this one? Recall back this one. This equation, the equation I showed you just now, the slides. Go back just now. Okay. How you know you need to find the rho when the diagram do not give you the radius? When you see the question that the object is having a drift or having in a curvature motion, and the object asks you to focus on the object, and then you see the question ABC part, it asks you to find tangent component, normal component under this section. And if in the diagram or in the question itself do not give you the curvature radius, you need to use the equation that I give you just now. If it's given, the substitute. If you do not give, you need to find by using the differentiation equation that I give you just now. Yeah, remember these slides, and then this equation, and then the equation for rho. And then, of course, remember to find magnitude every time. Okay, go very fast here. Okay, recall these 3 equations and this equation. This one, if you don't know how to press calculator, go and practice how to press exponential 3 and divided by 2. Go and practice your calculator. Okay, let's practice the theory part. Apply the theory part. Okay. Now you have a skidder. Okay, how you know that you need to use is a fall under normal and tangent question. You know the question? The sky scalar reach point A on the parabolic path. When you see parabolic, it's fall under this section. And something sliding. Something sliding, and it give you a curvature or a circle. That one fall under this one. He has a speed of 6 meters per second and increase at 6 meters per second square, and increasing in 6 meters per second square. You are given the acceleration. Determine the direction of his velocity and direction and magnitude of his acceleration at this instant. Ignore the size of the skitter in this calculation. This one is important. If you see ignore the size, means it's not under a chapter that need to find energy. The M is taking out. Okay, so this one you are given in the tutorial question. You have the X and Y. This is a global axis. Don't confuse by the global axis. And it asks you to find important. It asks you to find direction of his velocity, means object. It asks you to focus on the object. That means you need to find tangent and normal. Yeah. If you see position, means projectile question. There's a keyword there. If you see position, means you need to answer in the projectile question. If you see his or it or something that focus on the object, then it's the normal tangent question. All right. Now, given an equation, this is a parabolic question or is a quadratic equation, and you're given a height of 5 meters. Okay, observe the steps. It's always standard. You have 10 meters from the endpoint, 5 meters to the object. First step, First step, draw where is your normal and tangent axis. Here, you know the object is going on the curve. You can draw normal and tangent. Just draw like this, you get 1 mark. Just tell me where is your tangent positive value. Following the object motion, draw straight line. 90 degree is the normal axis. This will give you 1 mark for axis. Okay. Then put in the motion information with its velocity and acceleration. Okay. Now VA is given 6 meters per second and with an angle. Yeah. With an angle from the horizontal plate. Okay. Can ask. Later. Later. After you draw the A and T, then you work lah. Cuti. Yeah. So basically, you can import your object out and then you draw something like this. Or you can just use the diagram, no issue. But on the question in your test, you need to export the question out in your answer. You need to draw something like this, or you can draw the whole diagram. You don't need to draw the object shape in detail. You can represent as one big dot, one big circle. Right? Any question on this part? Tangent and normal? No. Put in the vector velocity. Who have question why I can draw VA in this direction, in tangent direction? It's always tangent. Velocity always tangent to the curve. That's why here you can put in the 6 meter there. Then with the angle. Any question on this diagram? Anyone who have problem developing this diagram from the question of or this diagram? Tak ada, boleh ya? Okay. Now they put in the equation y equal to 1 over 2x squared. Does this question tell you the radius? Do you know the radius or not? The curve radius, do you know or not? In the question, do you give you the question the radius? No. 10 is not the radius. 10 is just a position from the endpoint to the object. Is to find the radius. Find the radius by differentiating the y equation. This part I skip, is your mathematics skill already. So you do dy dx, you get 1 over 10. Then you need to do double differentiation again to substitute inside the equation just now. This one, If you're not given the curvature or the radius, you need to find dy dx. You need to find d double differentiation of your y equation. And then substitute inside here to find the radius. Yeah, here we continue. First, draw the diagram, put in the motion V or A. A is not given, so never mind. So here you do the differentiation first. Y equal to something, you do dy dx, you get the number. So you know that your x is 10. You know that your x is 10. You see this one as Cartesian. You are given a line with dy dx. So you calculate dy dx when it's 10 meter from the ending point, which is your x value. Dy dx is 1. Okay. If you don't know what is dy dx, is the one that I show on the screen there. So if you have dy dx, you know that the angle is 90 degree. Because you know that dy dx actually is the tangent theta. This is the angle, theta is here. Theta is here. So tangent is what? Opposite divided by the side, or dy dx. So if your dy dx is 1, so tangent 1 is 10, inverse 10 is what? 45 degree. Yeah. This is, we assume you know already. We assume you already know. X is here. This value. This one x. What does it mean, is it? X here is your x value. The x value is 10. It means dy dx is what? Is finding the gradient, right? Gradient at this point, right? So where is your x? X is here, right? Here to here. Here to here is what? 10. Yes. But in this case, you don't need to see it as gradient. You just see it as a mathematical equation. So the answer VA is 6 meters per second, go down. Angle is 45, go down. Who don't understand why I draw 45 going like this? Although my angle is 45. Although my angle here is 45. Who don't understand why my vector is 45 go down like this? Who cannot get it? Why I can draw 45 go down like this? Because I transfer this angle to another side of here. Look at your face. I know you don't understand. Okay. Here you find is 45. Right? You can transfer the angle here to here. That's why I can draw my vector velocity 45 go down. Okay, once you have the angle, you need to find acceleration. Acceleration equation is given. An equal to v squared over rho. Fixed already, yeah? Fixed already. Okay, fixed already. Here, increasing at 2 meters per second. This one is what? Acceleration what? This value is what? What direction? Normal or tangent? This value, 2 meters per second square. What does it, what is this direction? Normal, what normal? It tell you that he had a speed of 6 meters per second, which is increasing at 2 meters per second square. It's going down like this. Velocity, tangent, you know. Then this value, 2 meters per second, what is the direction? Is it normal or tangent? Tangent. Okay. Just now someone say normal. Okay, remember these slides. Again, I highlight this slide is important. Okay. So you have the A equal to AT UT plus AN and the magnitude you know. A equal to square root of something. And AN you can calculate. Okay, you use the on the top one, this equation. A equal to V naught UT plus V squared over rho UN. So on the graph, on the diagram, you need to draw the tangent and normal direction for acceleration. Okay, either you use different color of pen, or you use different. You can use dot, line, arrow for acceleration. As long as I see there's a different line for velocity and acceleration. Okay, any question if I put the red arrow line like this? The one that given in the question always follow the object. Always follow the object. So AT is 2, AN is going in, and you already given the AT component with its V dot, and the AN component is V squared over rho. And you know that you are solving a vector question again. If you draw a parallel line, this is your A, resultant A, right? And the angle is phi. So there's a necessary to calculate the radius. Why? Radius is not given because you need the radius to calculate for AN component. So call this equation out. Y equal to something. You do dy dx, you do d square y and dx square. So dy dx equal to 1 over 10x. The double differentiation of your y, you get 1 over 10. Okay. Now, when you substitute the value here, don't straight away substitute the x value there. Substitute what you get from the differentiation. If you see x, still use the x substitute inside there. Why? Because there's a square and the square root and the cube there. If you substitute value there, you won't see the effect of x. Put in there. Okay, and then you substitute the x as 10. put the 10 there. X is 10. The X from the is given 10. Huh? So the rho is 28.28 meter. Try to observe the way we solve. Huh? Try to observe the way we solve, and it's fixed already. Every time you see curvature with the normal tangent, then it's fixed already. It's going this way. Huh? Huh? All right. Now, once you have, you just substitute value in. A equal to AT UT plus AN UN. AT you already know is 2. B you know, and this one is V here is 6. Velocity here is, again, I just highlight, and this one is not inside my slide. The V square over rho, the value of V here, we use tangent velocity. The V value here is not V normal. It's, you use a V tangent value. It's not inside my slides. Huh? This one. V dot is acceleration. V dot is AT, sorry. Here, just don't like say that, oh, I don't have value of Vn. V square over rho, the V here, you use Vt value, tangent value. So you use 6 and then substitute. And you write in the vector form. In the vector form, A equal to constant value, T unit, and then constant value, N unit. Then you need to find the resultant, which is square root of this one, square root of this one, right? Square this one, square this one, square root. Okay. Get one value. UT is given. UT is 6. Sorry, VT, not UT. UT is just a unit. UT is just a unit like your IJK in X, Y, Z axis. And you use this angle, this triangular. Tangent is opposite divided by side. Opposite is 2. Side is 1.273. It's not, it's just a unit like your IJK in global axis. No, it's just a unit, vector unit in tangent and normal. Okay, once you find the angle between the two vector, you can find the resultant acceleration is 12.5. From the horizon. For this kind of question, we always interested in the angle from the horizon. Like this. This is a complete answer. I already show you this one. You go and read this put in this one. Okay, I even put in the slides. Okay. Okay, the next one I go very fast. You just observe the steps. What you need to do. Okay, so if you have a car that go in the circular, so you know that this is focusing on the car because it tells you that it's in the horizontal circular track that have a radius. Radius is given, so you don't need to calculate the radius. If the car increase the speed at a constant rate of 1.5 meter per square, your A is given. And again, the A given here is your AT, the object acceleration. Starting from rest, you're given the V value. Determine the time needed for it to reach an acceleration of 2 meters per second square. What is the speed at this instant? So you need to find the V when you reach acceleration of that one. So given the radius, so observe the step. First, put in the axis of normal and tangent on the object. The first step. So where is the tangent? Go down. Where's the normal? Here. If you don't know, use your hand. Okay. So normal, tangent. Okay. First step, draw the axis. Second step, put in the motion value or motion parameter, acceleration or velocity that is given. So in this case, you have your AT. So AT along the tangent, that one, AN go inside the circle. And then there's a resultant of A. Okay, once you have that one, you write the equation for the resultant, A equal to square root AN square plus AT square. And you need to find the angle also, right? The angle later. So you know that this is curvature circle, and you need to find AN. Recall the equation. This one costs you 1 mark. AN equal to V square over rho. You have the rho. Rho is 300 meter. What is the V? Need to find, right? Do you have AN? Don't know. Don't have, right? So again, use the three motion equation. Use the three motion equation. So V equal to VO plus AT. Why you can use three motion equation? Acceleration is constant. Increase as speed at constant rate. Once you see so from there, put in side to find the resultant of A. They put in there. And from here, you already know the resultant is given. The resultant is 2. The resultant is 2. So there's only one unknown. Solve the equation, you get the time. It's 13.28. Again, a reminder, this question might come out in your assignment. You need to do the substitution in the steps. If this question come out in your assignment, basically you need to tell me what is your steps and then the final answer. If you skip the substitution, you won't get full marks. Your assignment, let's say this question is 10 marks. If you just follow, copy exactly, maybe you just get 7 or 6 marks. Ada kelas eh? Ada kelas tu? Tak ada. Okay, 3 more minutes. Then we see you next week. Okay, this is the application of curvature motion. If you have problems of this industry conveyor, and you need to send the object to one location, right? Travel on the conveyor. If the box starts from rest, the V is given. Increase speed as acceleration is given, where a determine magnitude acceleration when it reach point B here. Okay, is drift or not drift lah, but there's a curve. You know, we go to the structure after you define the object. So you go to the tree, and then first step always go where the tangent is. Here, normal inside, and tangent. Then the box start from zero. Start from zero from A point to this point. Can find, right? You already given the 3 Newton equation. This is a straight line, rectilinear motion. So calculate the speed from here until here, right? So, and you're given the AT, 0.2. Substitute into the 3 Newton equation. Okay, AT equal to 0.2 T, A equal to dV dt, A equal to dV dt. So this is the equation. Rearrange, you get dV equal to something. And you see d something, integrate, you get V equation. This is a bit different from statics. Dynamic, you need to derive equation from the question itself. Okay. So once you get a V, you can find the time to reach B. Yeah. So V equal to ds dt equal to 0.1 t squared. Again, derive equation again. Rearrange the equation, you get ds dt, integrate, you get one equation, SB one equation cube. Yeah. Now basically is to see it as rectilinear motion and curvilinear motion. Okay. Ignore the mathematics just now for this question. Observe the steps. Once you have the equation, you can substitute. What is the distance to travel from A to B? This is a primary school mathematics. Total distance traveled 3 plus the curve. You need to recall the curve S is pi r 2 pi r 2 pi r S equal to r theta, right? S equal to SR, no, r theta, sorry, S equal to r theta. Okay, 2 pi r. So you substitute. Okay, why quarter is because it's only quarter of the circle. One circle is 2 pi r. The circumference of the circle is 2 pi r, but this is only quarter. So that's why we divide by 4. You find the SB, substitute inside this equation, you get the time. Okay, once you find, you substitute inside here. You have the time already. Substitute here. Find the V. Once you have the time, you can find AT. Okay, the rest is substitution. Once you find AT, you can calculate AN equal to V squared over rho. Quite standard, this one. So rho is given. Rho is 2 meters. V you already find. You can find AN. After you find AT and AN, remember to find the magnitude, which is square your value. Okay, then we stop here. Okay, sign your attendance.